Hello, this is Mrs. Edwards, and we are going to work through the CCG review and preview for 8-6 to 8-12. 8-6 says solve for x in each diagram below. So remember, when we're working with our triangles, we need to keep in mind that all the angles of our triangle, all our interior angles of the triangle add to 180 degrees. We need to remember that supplemental angles are straight lines and they equal 180 degrees. If we have an isosceles triangle, our two base angles are congruent. And sometimes we have to fill in some of the missing pieces in order to solve for the variable that they are looking for. So on question A, they give us two angles, so we can solve for the third angle by doing 180 minus both of those, which tells us that this angle is in fact 70 degrees. So then, knowing that this is a supplementary angle and equal to 180, we can then solve for x by taking 180 and subtracting that 70 from it. So we know that x is 110 degrees. Looking at letter B, we know that a supplementary angle is 180. So if we do 180 minus 140, that tells us this angle measure, which is 40 degrees. So we needed to find that first in order to find our base angles. Notice that the sides of our triangle are congruent, which means our base angles are also congruent. So if a triangle adds up to 180 degrees, we can subtract our top angle, or our 40 degrees, out. So we get 140 degrees. We know that our base angles are equal, so if we divide 140 by 2, we get x is equal to 70 degrees. Looking at example C, again, we have a supplementary angle at 148, so we can find this piece by taking 180 and subtracting 148 from it, which gives us 32 degrees. So we took 180 and we subtracted 148. We then can find our x value by all of the triangles add up to 180. If we subtract 100 degrees, we subtract 32 degrees. That will give us our angle measure, which would be 48 degrees. Looking at our last triangle, we can see that our top angle is 36. So if we subtract 36 from 180, that tells us that the bottom two angles have to add to 140 degrees. We know that our base angles are equal, so if we divide 144 by 2, it tells us that our base angles are 72 degrees. And then in order to find x, we know that this is a supplementary or a straight angle. So if we take 180 and we subtract 72 from that, we know that x is equal to 108 degrees. 8-7, using the definition of a polygon from the math notes box in this lesson, determine whether each of the following figures is or is not a polygon. Justify your decision for each figure. So when we think about the definition of a polygon from our math notes box, they stated that a polygon is a two-dimensional figure. So a polygon is a two-dimensional figure made up of straight lines and those lines connect end to end. So looking at example A, this curve tells us that this is not a polygon. When I look at letter B, I have a shape that is connected using straight lines, so it is a polygon. When I look at C, these shapes connect, but it's not one connected shape. So this is not a polygon. D consists of straight lines connecting end to end. So this is a polygon. E would be a no, not a polygon. F, straight lines connect end to end, so it is a polygon. G, straight lines connect end to end, so it is a polygon. H, we're missing this piece right here, so it is not a polygon. After solving for x in each of the diagrams in problem 8-6, Jerome thinks he sees a pattern. He notices that the measure of an exterior angle of a triangle is related to 2 of the angles of the triangle. Do you see a pattern? To help find a pattern, study the results from 8-6. Letter B says, in the example below, angles A and B are called remote interior angles of the given exterior angle because they are not adjacent to the exterior. So remember, adjacent means connected. So these two angles are not connected to this exterior angle, X. Write a conjecture about the relationship between the remote interior and exterior angles of the triangle. So we can say that the measure of an exterior angle equals the sum of the two remote interior angles. Prove that the conjecture you wrote for part B is true for all triangles. Your proof can be written in any form as long as it is convincing and provides reasons for all statements. So looking at the triangle to our right, we know that if we take angle A plus angle B plus angle C, it equals 180 degrees. So the sum of the interior angles is 180 degrees. We know that if we take angle X plus angle C, that is a straight angle, and that equals 180 degrees. Therefore, we can use substitution. We know both of these equal 180 degrees, so A plus B plus C must equal X plus C, and we use substitution for that. Therefore, when we subtract C from both sides, we get A plus B equals X. So our remote interior angles equals our exterior angle. Examine the geometric relationship in the diagram below. Show all of the steps in your solution for X and for Y. So looking at all of these angles for X in this pentagon, I know that a circle adds to 360 degrees. So if we take the circle 360 degrees and divide it by the number of triangles, which is 5, we get x to equal 72 degrees. So the interior corresponding angles are 72 degrees. In order to find y, I know that all of my angles inside my triangle equal to 180. We know x equals 72 in this case. So using our inverse operations, we can take 180 and subtract 72 from that, which gives us 108. So 2y equals 108. We can divide by 2. So we know y is equal to 54 degrees. 8-10 says Stephen has 100 congruent triangles that each has an angle measuring 15 degrees. How many triangles would he need to use in order to make a pinwheel? So when we made our pinwheels, remember the interior angles. So interior angles added to 360 degrees. So if we know we have 100 congruent triangles and all of them have an angle measure that is 15 degrees, we can use the 15 degree angle measure as our corresponding angle. So if we take 360 and divide it by that corresponding angle of 15 degrees, we know that we will need 24 triangles to create a pinwheel. Eight 11 says find the value of x in each diagram below if possible. If the triangles are congruent, state which triangle congruency property was used. If the triangles are not congruent or if there is not enough information, state cannot be determined. So looking at example A, I have two parallel sides for my quadrilateral. When I have parallel sides, I know that my alternate interior angles are also congruent. So I can deem that this is 28. I also know that this angle is 73 degrees, which tells me this angle also must be 73 degrees. I have a shared side, so based on angle, side, angle congruency theorem, I know that my triangles are congruent. I also could have used side angle side because I also noticed that this side is a length of 7. This base of my triangle is also a length of 7. So using either the teal 73 degree angle or we can state that based upon side angle side congruency, our triangles are also congruent. In order to solve for x, though, we know that all the angles of a triangle equal 180 degrees. So if we subtract out our 28 degrees and our 73 degrees, we know that x is equal to 79 degrees. Looking at example B, I noticed that this angle is 23 degrees and this angle is 23 degrees. So if I draw my triangles so that I can see both 23 degree angles next to one another, or so you can tell that they are corresponding angles, and I label both of my triangles. In this triangle, my 9 is opposite of my 23. In this triangle, my 9 is adjacent to my 23 degrees. So we cannot determine whether these are congruent or not because we don't have enough information. Looking at example C, I have two triangles and 16 appears across from my right angle in both triangles. My 30 degree, if I redraw my triangles, my 30 degree appears to be adjacent to my 16. My 30 degree also appears to be adjacent to my 16. So in order to find x, because these triangles are congruent, we can find this bottom piece using our right triangle trig. So adjacent and hypotenuse is cosine. So if we take the cosine of 30 degrees, it equals our adjacent side over our hypotenuse. Use inverse operations. Tells us that our adjacent side, or the base of that triangle, is approximately 13.86. We could also find this leg of our triangle using right triangle trig. So the side, when we use the adjacent side, this teal work over here, it is actually, adjacent is next to, so I'm so sorry, we actually found this side length, 13.86. We can find the base using the opposite, because this side is opposite, and sine is opposite over hypotenuse, so 30 degrees equals our opposite over our hypotenuse, which is 16. We again use inverse operations, so 16 times the sine of 30 is equal to 8. So our opposite side is a length of 8. So if we take 13.86, which is this side, 13.86, subtract 8 from that, we are left with approximately x equal to 5.9 units. We also know that based upon angle, side congruency, that these triangles are congruent. Moving on to letter D, we are working with two right triangles that are laying on their long legs. I noticed that this center part is 7 and this taller part is 2. So if you drew your triangles back to back separately, I would know that this side is 9, this side is 9. These sides are congruent, which they told us was 5, so this side also has to be 5. They told us these were 90-degree angles, and they want us to solve for x. So if we are looking for an angle measure in a congruent triangle, so we can say that these are congruent by side, angle, side, congruency, side, angle, side. To solve for x, we can use our inverse trig functions. So if we use inverse tangent, tangent is opposite over adjacent. So this is O, this is A. So 9/5. When we type that into our calculator, remember to push your inverse tangent button. You get x is equal to 60.9 degrees. 8-12 says decide if the following statements are true or false. If a statement is false, provide a diagram of a counterexample. All squares are rectangles. This is a true statement. All quadrilaterals are parallelograms. Well, this is a false statement because there is, if we have a trapezoid, for example, these two sides are parallel, these two sides are not. So there are quadrilaterals that are not parallelograms. Because a trapezoid does not have two sets of parallel sides. All rhombi are parallelograms is a true statement. A rhombi is just a more defined parallelogram because a rhombus has all of its sides are congruent and a parallelogram does not have to be. All squares are rhombi. Again, this is a true statement. A square has two sets of parallel sides. All of the sides are equal, and the difference between a rhombus and a square is a square has all right angles. And letter E says the diagonals of a parallelogram bisect the angles. So if we look at a parallelogram, we cannot say that it bisects the angles, so this would be false, because if we think of a rhombus, a parallelogram is not a rhombus. So any parallelogram that is not a rhombus, our angles, the diagonals, would not bisect the angles.